mind helping me?
Hey, Miss Waters. What's going on?
To explain this one concept that's a little bit more difficult for my students, and I thought maybe you could help me clear it up with them.
It looks kind of complicated. We'll see what we can do.
Okay. If you will, we're going to be talking about electron configuration, so have out your reference table, and I want to go over something with you. All right, so here are 3 examples of nitrogen. Now, how do I know that they're nitrogen? Nitrogen has 7 electrons. So if nitrogen has 7 electrons, and the electron configuration looks like so, 2-5, notice that there's 2 electrons that are going to be in the first energy level. So we say 1s2. In the second energy level, there's 5 total electrons. Notice up here, the second energy level includes the 2s and the 3 2p's. So what I'm going to end up having is, in the second energy level, I'll have 2 electrons in the s, and then the rest of those 5 electrons that are in the second energy level must go into the 2p. And how many are left there, Mr. Webster? If I have 2 already in the second level, out of the 5, how many have to go into the p?
Oh, there's got to be 3.
There's got to be 3. Okay? So that's what we're looking for. We're looking for 7 total electrons. 2 of them have to be in the first energy level. 5 of them have to be in the next energy level. And they must fill up in order of the lowest energy first, which means the s, and then the higher energy, which is the p. The s can only hold 2 electrons.
That makes sense.
All right, so let's look at our first example of what the student is saying. The student is saying that, yes, there's 2 in the 1s. Awesome. Over here, though, they're also saying 2 in the 1s. And in the last example, they're saying 2 in the 1s. So all 3 of these are correct for the 1s. Let's now turn to the 2s. This student is saying that there's only 1 electron in the 2s.
Uh-oh.
That right there is a mistake. Okay? These 2 examples here say that there's 2 in the 2s here as well as 2 in the 2s here. So far, these 2 examples are the better examples. Now I have to look at the 2p and see where the 3 electrons are. In this one, they're showing 3 electrons, each in a single little space by themselves. And that's what we learned about. We learned that electrons are going to take available space before they double up. So if you look at this last example, we have 2 electrons that are sharing a space when there actually is an available space here for one of them. So the best of all of these diagrams is this diagram here. So Mr. Webster, I'm going to ask you to help me out with a few more examples here. Sulfur has a symbol of capital S. And it has, if you look on your reference table, Mr. Webster, how many electrons should I be showing for sulfur?
Sulfur has 16.
16 total electrons. And what's electron configuration? It's 2-8-6.
So 2 plus 8 plus 6 is 16.
Very good. So I should have, in my first energy level, 2 electrons. So the 1s has 2 electrons.
Okay.
In the second energy level, I should have a total of 8 electrons. So I have, in the second level, I'm going to have those 2 that always go into the s. And then how many would I need in the p to make 8 total electrons in my second energy level?
You need 6.
You need 6, because 6 and 2 makes a total of 8 in the second energy level.
Right.
That means that this 6 electrons has to go into the third energy level. So I have my 3s always holds 2, and then how many will be left over to go into the 3p?
It would be 4, because 2 plus 4 is 6.
Very good. 2 plus 4 makes 6. Okay? So let's do it. Let's go up to our diagrams here to show each of the separate levels. And let's put our electrons in. I need 2 in my 1s. So I need 2 in here, and notice that I'm putting the arrows going in opposite spins, one going up, one going down. In my 2s, same thing. I need 2 electrons, one going up, one going down. Now for the tricky part. These 6 electrons that need to go in these 3 spaces are going to go in this order. You always start with the available space first. So there's 1, 2, 3, no more available space, so I have to double up, 4, 5, 6 electrons. Those are the 6 electrons from the 2p. And then I have 2 in the 3s. I'm going to show them again in opposite spins. And what will I do with the 3p? Available space first, 1, 2, 3. I need to show a total of 4, so I'm going to come back and double up. Tell me what I'm going to do with silicon. You're on a roll, Mr. Webster.
All right, so we start off, we have to look at the reference table and find silicon. It says there's 14 electrons. Okay, so if there's 14 electrons, that means first we do that. So 2, 8, that makes 10, so there's going to be 4 left in the third shell. Okay, now we got to do 1s squared, which is 2 electrons in the first shell. And in the second shell, we got the same thing, 2s with 2 there, yep. And then we're going to have, to make that 8, we got to get 2p6.
Very good.
And then for the third shell, we got 4. So it starts off, we're going to have 3s2, and then 2 plus 2 is 4, so it's got to be 3p2.
Good.
Yeah. And then we're going to have an up and a down, and then an up and a down. And then to fill in here, we're going to have a total of 6, and so it's going to go up, 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 and then go back, top, yep, down, down, down. Great. And then we're going to have an up and a down for the 3s2. And then the last 2, we got to fill in just 2 going up, so 1 in one box, 1 in the next.
Awesome. Okay, I hope you guys got the hang of this, and you're going to need more practice on this, but definitely take a good look at what you've learned so far and see if you can fill in for neon. Now we have what's called element X, and this is a very common type of question that's on your exam. So element X, we need to first figure out, well, what is element X? And the way to find that out is to basically count how many electrons you have. So how many electrons do you have here?
On the 1s shell, we got 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10.
So I have 10 electrons that are being shown.
Now, they made a mistake, didn't they?
They did make a mistake. But what they want us to do first is at least let's identify which element this is.
Okay.
So if it has 10 electrons, what element are we talking about here?
Well, if I look at my periodic table, it says that 10 is neon,
Okay. And what is the ground state electron configuration for neon? Well, we have the 2, and then
It's got to be 8, yep, and that makes 10.
okay. So, is this arrangement, and Mr. Webster, you just noticed that this arrangement that they're showing is not right. There's something wrong up here. Okay? And if this arrangement were correct, what would we be showing? Well, we show the 1 has 2 in it, so it's a 1s has 2. And then the 2s would have the 2, and what would the 2p have to have?
2p would have to have 6.
To make up that the rest of that 8. So what's wrong up here? So they basically have a 2 for the 2 here, dash 7,
And
right?
then
1, 2, 3, 4, 5, 6, 7, and then a dash because in the third energy level they have 1.
That's not right.
That's not right. What this is saying is that one of the electrons, instead of staying at a lower level, has jumped up to a higher level. So this is called the excited state. So for your exam in Regents Chemistry, you will have to be able to recognize excited state elements. We'll do some more practice in class, and we'll see you there.
Good luck.